If you stood at the edge of the universe and looked out, the sight before you would drive you insane. Not because of a patch of pure darkness,
It just stops.
not because
There's
of another
nothing here,
universe,
absolutely
but because
nothing.
of absolute nothingness. But if you think of it that way, you might already be wrong. Because the very phrase outside the universe is already a trap in itself. The universe is the sum total of all space and time. To ask what lies outside the universe is like asking, what space lies outside all of space? That is a contradiction. But the human brain refuses to accept this answer. We are born imagining that everything must have a boundary. The house you live in has walls. Earth has an atmosphere. The solar system has the Oort cloud. So when we think about the universe, our brains automatically put a shell around it. But the universe may not have this shell at all. The sun you see is the sun from 8 minutes ago. The North Star you see is the North Star from 430 years ago. The farther away you look, the further into their past you are seeing. And the most distant light comes from 13.8 billion years ago. That was the era when the universe had just formed. Before that, the universe was filled with searing hot plasma. And in such an environment, light could not travel far at all. So the farthest limit we can see is not the edge of space itself. Scientists call this boundary the cosmic horizon. The things beyond it do not fail to exist. It's just that their light hasn't had time to reach us yet. But there's an even stranger problem here. Because the universe is expanding, and that expansion is speeding up. Some light from galaxies that are too far away will never reach us. The light they emit is chasing after us. But the rate at which space itself expands is even faster than that of light. So light from beyond our horizon will never reach Earth. In 2021, the James Webb Space Telescope was launched, and it can see galaxies that are more distant and ancient. But even with this super powerful telescope, we still cannot see anything beyond the horizon. Because what limits us is not our instruments, but the physical laws of the universe. It's like a person standing on Earth. No matter how high he jumps, he can never see the scenery beyond the horizon. Because Earth is curved. Speaking of curvature, the universe itself may also be curved. Einstein's general relativity tells us that mass bends space. A bowling ball placed on a trampoline will create a dent in the fabric. And that's what we mean by curvature. In the universe, there are countless stars, galaxies, and black holes, all of which bend space. If you add all that curvature up, what is the overall shape of the universe? Scientists have measured the cosmic microwave background radiation and found that, on the whole, the universe is very close to flat. But close does not mean perfectly flat. The universe may still have an extremely slight positive curvature, which would mean the universe could be a gigantic sphere, not a simple three-dimensional sphere as we imagine it, but a four-dimensional hypersphere. If this is true, it's absolutely mind-blowing. Imagine walking along what feels like a straight line on this hyperspherical surface, and eventually realizing you've come back to your starting point, not because you turned around, but because space itself is connected. Just like the surface of the Earth. If you keep walking east, you'll never reach an edge. You'll eventually come back from the west. A four-dimensional hypersphere would behave the same way, just with one extra dimension. And our brains are completely incapable of drawing that shape. But some scientists also believe the universe might have a more complicated curvature, like a saddle, or that it may have an even more complex structure, such as a torus or a Klein bottle. In 2003, French astronomers analyzed cosmic microwave background data and proposed that the universe might have the shape of a 12-faced polyhedron, with each face connected to its opposite face. If you flew out through one face, you would re-enter through the opposite one. It's like playing Pac-Man. You disappear off the left side of the screen and reappear on the right. All of these theories point toward one common conclusion, that the universe may have no boundary, and yet still be finite in size. Just as Earth's surface is finite, but you can never find an edge to that surface. The universe may be the same way, not truly infinite, but a finite space without borders. So how big is the universe really? If the universe really is a hypersphere, then, according to current curvature measurements, its actual diameter is at least 250 times the diameter of the observable universe. But that's only a lower bound, and in reality, it could be far larger. We will never truly know, because we will never see beyond our horizon. So what's the point of this discussion? Some people say it's meaningless, that it goes beyond the scope of science. But some scientists don't think so, and they've put forward a bold idea. Maybe we can't see beyond the universe, but we might be able to feel its influence. This idea comes from quantum mechanics. Quantum entanglement tells us that two particles can have an instant connection, no matter how far apart they are. And the speed of this connection seems to exceed the speed of light, even though no usable information is actually transmitted. But why can two particles ignore space to form such a link? One explanation is that our universe may be a projection of a higher dimensional space, like 2 points on a sheet of paper. On the paper, they might be very far apart. But if you fold the paper, those 2 points can be very close in three-dimensional space. Our three-dimensional universe could be like that too, just the surface of some higher dimensional structure. And this is one of the core ideas of string theory. String theory suggests that the universe may have 10 or even 11 dimensions. We can only directly perceive 4 of them, while the others are curled up at extremely small scales. These extra dimensions are like a string. From far away, it looks like a simple line. But if you were an ant walking along that string, you'd realize the string actually has thickness. It's a tiny cylinder. If string theory is right, then what lies outside our universe may simply be those extra dimensions we cannot sense. They are not in front of or behind us, to our left or right, above or below, but extend in the directions of other dimensions. We simply cannot picture those directions in our minds. An even bolder idea is the holographic principle. And in 1993, physicists proposed that our three-dimensional universe may be nothing more than a holographic projection of a two-dimensional surface. It's like an IMAX movie. It looks three-dimensional and deep, but in reality, all the images are just being projected onto a huge two-dimensional screen. If this is true, then the distances and volumes we perceive may be nothing more than illusions. The universe might fundamentally be a two-dimensional membrane, and we are just ripples on that membrane. If the universe is a holographic projection, then outside is simply that true two-dimensional surface. And the stars and galaxies we see in space-time are just a three-dimensional representation of information on that surface. This would mean we can never step outside the universe, because no matter which way we travel, we're only moving around inside a three-dimensional projection. We will never touch that underlying surface. But there is another possibility that is even more astonishing. If our universe is finite, then where did it come from? The Big Bang Theory says the universe was born from a singularity 13.8 billion years ago. But what about before that singularity? Many people will say there was nothing before it, because time itself began with the Big Bang. But that answer is not complete. In 2010, Roger Penrose proposed the model of conformal cyclic cosmology. He argued that the Big Bang might not be a beginning, but a loop point, that the previous universe died in a state of thermal equilibrium, with all matter decaying into radiation, and the entire universe turning into a homogeneous ocean of photons. In that state, time and space lose their meaning, because there is nothing left to serve as a reference for distance or order. And this dimensionless state may be equivalent to the initial state of the Big Bang. In other words, the endpoint of the previous universe is exactly the starting point of this one. The universe would keep dying and being reborn, and each rebirth would reset the laws of physics, creating new stars, new galaxies, and new forms of life. And we are just one round in that endless cycle. If the universe is cyclic, then outside may simply be other cycles along the time dimension, the previous universe and the next, which do not lie outside our space. This kind of outside is something you will never see, because it has either already ceased to exist or has not yet happened. But whatever the true nature of the universe may be, for us, simply standing at the edge of our understanding, facing the unknowable void, and still holding on to curiosity and awe, that is the most precious courage of human civilization.